This is the last video for lesson 5.3. We will be finishing off our practical application question. We had done A and B in the previous video, and now we're going to finish off C, D, and E, and then we're going to do a little sketch of the graph. So from what height was the rocket launched? What that basically means is at time zero, what was the height? Were we on the ground, or were we standing on some kind of cliff? Where were we? What was happening? So all we have to do is solve for time zero. So we have height is equal to -4 times 0, that's what we're replacing our t by there, minus 3 squared plus 64. And so if we continue here, we have h is equal to -4 times -3 squared plus 64. And I'll continue the work just on the side over here. So h is equal to -4. -3 squared is 9 times 9 plus 64. And so we get h is equal to -36 plus 64. And so what we get is therefore h is equal to 28 meters. Therefore, the rocket was launched at 28 meters. So you might have been standing on some kind of cliff, on stairs or something, but you were elevated when you launched it. You weren't necessarily on the ground. So for example, if this is the ground here, you might have been standing maybe up here, climbed up a hill, and then you launched it from up there, and then it went up, reached height of 64, and started coming back down. So that's the general idea for how the launching occurred. You weren't necessarily on the ground, you were up here somewhere at 28. And so that, you can probably guess, is your y-intercept, because it's when your x is 0. So at 0, you're at 28. When did the rocket hit the ground? So what does that mean, when did it hit the ground? What does the height have to be if you actually hit the ground? So here's the ground here. Think about this like a grid. This would be height 0. So when you hit the ground, you're at height 0. So what you're trying to find is the time when you were at height 0. So what we can do is plug in our 0 into our equation for h. So we have 0 is equal to -4 times t minus 3 squared plus 64. And what we can do is we can start solving for the t. We can first send our 64 to the other side, or subtract 64 from both sides. So if I do minus 64 here, I have to do minus 64 over here as well. And so what I get is minus 64 is equal to -4 times t minus 3 squared. Then I can go ahead and divide both sides by -4. That cancels out the -4 over here. And that gives me 16 is equal to t minus 3 squared. Now I still need to get rid of that squared part before I can do anything else. What that means is I need to take the square root of both sides. So if I take the square root of 16 and the square root of t minus 3 squared, I get, continuing over here, square root of 16 is 4, is equal to t minus 3. The square root of t minus 3 squared altogether is just t minus 3. Now, in reality, we have the square root of 16 is actually plus 4 or minus 4. It can be one or the other. So I'm going to show you there's two possible solutions here. We're going to have to choose which one makes most sense. So first we'll solve for t, assuming that we have positive 4. So if we have positive 4 is equal to t minus 3, what that means is that we can just add plus 3 to get rid of the 3 where the t is, and we get 7 is equal to t. So one possibility is 7 seconds. Okay, great. Now, our other possibility is that we're dealing with minus 4 is equal to t minus 3. So add 3 here, add 3 here to isolate the t, and we get t is equal to minus 4 plus 3 minus 1 seconds. So you have to choose a reasonable answer. Does minus 1 seconds make sense? No, you don't have minus 1 seconds, but 7 seconds makes sense. That's actually a timing that you can use. Therefore, it hits the ground. You would do a complete sentence, but the rocket hits the ground. At 7 seconds. Why are there two answers? Well, remember that your parabola probably hits the x-axis at 2 spots. There's 2 zeros. But in this situation, the only zero that really makes sense is the 7-second zero, not the -1 second zero. Let's do question E. At what time was the rocket at a height of 48 meters? So basically we're saying when h is 48, what is your t? And so you're doing the same idea, except this time, instead of putting a 0 where your h is, you're going to put a 48 where your h is. And you're going to have to choose which answer, and then you're going to have to write down an appropriate answer based on what you get. So we have 48 over here is equal to -4 t minus 3 squared plus 64. I'm going to be skipping some steps or doing a bit quicker, but we have minus 64 over here. Whatever we do to one side, we have to do to the other side as well, just like that. And so we get minus 16 is equal to -4 t minus 3 squared. Divide both sides by -4. This cancels out here. So then we get 4 is equal to t minus 3 squared. Then you can square root both sides. And really you get two options. You get positive 2 is equal to t minus 3, or negative 2 is equal to t minus 3. And so what you do is you solve for both of these. So we add plus 3 to this side, plus 3 to this side, and we get t is equal to 5. And then plus 3 to this side, and plus 3 to this side. And we get t is equal to 1. And so you might ask, well, which one makes sense? And in reality, both make sense. Well, you launch your rocket, after 1 second, you might have reached 48, let's say over here. It keeps rising, goes up to 64, but then it has to come back down. So again, after 5 seconds, you're back to 48, right? What goes up must come down, and so you'll be at the same height, at all heights at least twice, except for that vertex there. You're only there for that one point, but you'll be at all heights twice. So the answer is that we really reach 48 meters, and that's why we put times here, at both, therefore at 1 second first, so 1 second, it takes us 1 second to get to 48 meters, we keep going up beyond that for 9, 50, 51, up to 64, and then when we come back down, we go back to 48 meters again, right? It's like when you throw something from the ground, it goes up, and then it comes back down to the ground. So it goes up to 48, goes up beyond that, then comes back down to 48, and keeps going down after that. So 1 second and 5 seconds. So in this case, both of these solutions there make sense to have 2 times. Unlike the case where it hits the ground, well, it's only really going to hit the ground once. It started off at 28 meters and it hits the ground once for this situation. So our last scenario is just sketching this graph. And we can sketch it using a few points that we actually already found. We don't have to go make another table. By answering all these questions, we found some points. We found, for example, let me just choose a different color here. We found the y-intercept was 0.28. It was launched times 0, 28 meters. So we can go here and put 0.28. There's a y-intercept over here. We know our vertex. We know our vertex is going to be 364. So we have 3 over here, and so 1, 2, 3, 64. There's our vertex. We know we hit the ground at 7 seconds. Where was it we found that? We found that over here. So we found at 7 seconds we hit the ground. So 7, 0. There's another point here. We can connect these dots, but before we do that, let's just go find some other points. We also found that at 1 second, you're at 48. So at 1 second, you're at 48. And we also found you're again at 48 at 5 seconds. So at 5 seconds, you're at 48. So we found all of those points through those examples that we did there together. And so what we can do is we can connect those points like that. You'd do a better job than I do. But basically, you started off over here. You launched it from 28 meters. You were standing at some platform 28 meters high. It went up. Took about a second to reach 48 meters. Then finally got to 64. After about, how many seconds was it? 3 seconds. Got to 64. Then beyond 3 seconds, we start our descent. So we come down. After 5 seconds, we're back to 48. We keep going down. Finally, after 7 seconds, we actually hit the ground. So this would be the parabola that best represents the modeling of this rocket's flight. If you continued the parabola this way, which you could, but it would be incorrect for this situation. And the reason it's incorrect for this situation is because we don't have negative times. But just to show you what it would look like, I'm going to do it in a dashed line. So we had found another 0 that didn't make sense. I think we said that when did it hit the ground? At -1 second. So here's -1, 0. You would then draw that in to connect it this way. But again, we're not going to include this because it's not part of our model, really, for the for this graph, for this rocket model situation. So you have to think about what you're going to include and what you're not going to include when you have questions like this. So we sketched the graph to model the rocket equation here. We have determined our maximum heights, when the maximum heights happened, where it was launched from, and all these different real-life situations or applications represented points on our graph. So by the end of this series of videos, you're able to do transformations of y is equal to x squared in the vertex form by drawing all the graphs on the same grid. You can use either a table of values or a mapping rule, and you're able to interpret what questions mean when they pertain to a graph in the vertex form and other forms as well. Again, you have your zeros here, so you should know what your zeros mean as well. And you have your vertex, so you should know what that means. And you should be able to take a look at this graph and see that it makes sense. So for example, we have an A that's negative. So that means that our graph does open from the bottom. So there's many ways to verify that you're on the right track. You simply need to know where to find those key pieces of information.